In our previous video, we wrote a very important statement about the graph of our function f of x, where we said as x was approaching 3, the function values f of x was approaching 1, even though f of 3 was undefined. So for the above example that we did, we can use what's called limit notation to describe the behavior of the graph of f of x as x approaches 3. And if you'll recall, in fact, I'll go ahead and slide it back up here. This was the function that we were looking at. As x was getting closer to 3, the function was getting closer to 1, even though f of 3 was undefined because it gave us a 0 in the denominator. And we even said as x was approaching 3, f of x was approaching 1. And so what we're about to write is going to be our first limit statement of this class, and it's very important that we understand what is being expressed and what means what. So we want to say the limit, and underneath limit being abbreviated LIM, directly underneath that, you're going to describe what's happening to the independent variable. So we're going to say the limit as x is approaching 3. And that's how you would read that. The limit as x approaches 3. You have to be describing something. What happens as you start to work through some problems is sometimes people forget to actually state what they're looking at the limit of. You're looking at a function. Our function was f of x. So make sure you have some sort of function in there as part of your notation. The limit as x approaches 3 of f of x equals 1. And this conveys that as x is approaching 3, the function values are approaching 1. You also could have just written the function in there instead of f of x. We could have said the limit as x approaches 3 of x squared minus 5x plus 6 divided by x minus 3 was equal to 1. But you really want to make sure that you have whatever function is being referred to as a part of your notation. Otherwise, you're not really conveying an idea, or at least not the idea that you think you're conveying. In general, you'll see this as the notation here. In general, you will see the limit as x approaches c of my function f of x is equal to capital L. And this literally translates. So if you see this in the future, which you will, that literally translates into as x approaches c, f of x approaches the value L. So in the future, you're going to see just limit statements. Like you might see something like this, and you need to understand that that means that x is approaching a certain value, in this case c, and when x is approaching that value, the function is approaching the value L. And so we'll continue to work with this here over the next several lessons, but it's very important that you get the notation down before you actually start diving into limits.